does concentric mean?
Perfect.
No.
Good.
Inside of each other.
Inside of each other. Very
Better
good.
than
Okay, now in the center of all three of those circles is my nucleus. And we're just going to color that black.
I'll make it cool.
So there's my nucleus. Okay. And then we're going to put on my electrons. Now, this is where, again, you learn to use the periodic table. Let's go back to here. Based on this periodic table, how many elements are in the first row? 2. Hydrogen and helium. Remember I told you guys in the first shell there's how many electrons? 2. Well, how do I know that? You go to the first row. How many elements are there? 2. How many elements are in the next shell? Well, there's 1, 2, 3, 4, 5, 6, 7, 8. How many in the third shell? 8. When you get down to the fourth shell, all of a sudden there's, now you just count across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And so basically that tells you how many electrons you should have in each shell. Okay? Now, we know that sodium has how many electrons? Why do we know that's 11? Same as the number of protons. Okay. So if we come back over here, we're about ready to put on our electrons. How many go in the first shell? 2. So 1, 2. 2 electrons. So how many is left to put up there?
What was the question?
How many electrons does the sodium have altogether? 11. How many have we put up so far? 2. That leaves us with how many more? 9. Okay, good. How many go in the next shell? 8. Now guys, when we do this, this is the order you do it. You can start up here and you go 1, 2, 3, 4, 5, 6, 7, and 8. So now how many electrons is that?
Wouldn't that make 10?
That makes 10, so how many is left? And we have one more all right here, all by itself. Now we talk atomic theory. Based on this model, remember electrons want to have full outer shells. It makes them happy to be fulfilled, correct? All right. And major theme. Remember that sheet I gave you guys? Had all of the major themes of the course. One thing you might want to add to that is that nature is inherently lazy. And I'm not kidding. Write that down. Nature is inherently lazy. Inherently lazy. That is INHERENTLY. Inherently lazy. That's fine. Nature's lazy. Okay, so you tell me what's easier. How many electrons should I have in that third shell? In order to be a happy electron, how many should I have in that outer shell? 8. So I would need 7 more. So tell me what's easier. Finding 7 more electrons to throw in there, or getting rid of the one that I have?
Getting rid of the one.
Okay, so why don't you grab the middle one?
So if I get rid of that one, now I have my full outer shell, correct? Because my second shell is already full. Get rid of that extra one, I'm now a happy element. That's how bonding takes place. It's a lot easier to get rid of that one extra electron and give it away to somebody who's short an electron. Okay? That's why sodium and chlorine bond so easily together all the time. Okay, because chlorine needs an electron, and sodium needs to get rid of an electron. So they readily bond together. That's how you get sodium chloride. Okay, so all that bonding takes place is in this outer shell. And it completely depends on how many you need to get rid of and how many you need to fill. Now let me ask you this. Let's talk about reactive, not radioactive, but reactive. Elements that only have one electron or need to get one more electron. Is it easier for them to bond, or is it easier for the atom that has 3 electrons to receive?
Easier for them.
Why?
So it's more like, I don't know, it's easier just to get rid of one than it is to add on.
Well, think of it like this. How many of my fantasy players do we have here? Anybody that's ever done a fantasy league? No one's ever done any fantasy sports before? Okay. So, we'll talk a little bit about football then. Okay, let's suppose I'm your fantasy team. You're short 3 really good players, right? I need 2 really good running backs and a good wide receiver. Is it easier to fill all 3 of those spots, or is it easier just to fill the one spot? A lot easier just to find that one fill. And so, the fewer that you need, or the fewer that you have to get rid of, the more reactive that those elements are. And that's something so we can talk about that tomorrow as well. And this I thought you guys would like to actually see. This is the distribution of elements on Earth. So oxygen actually makes up, is definitely the most abundant element on our planet. Almost 50% of all the elements on our planet is made up of oxygen. Silicon is 25%. Remember we talked about oxygen and silicon? They together makes the silica mineral, silica compound. Kind of important. And then we have these other ones that are very, very rare. Now notice on here that gold and platinum. I think platinum's on there, isn't it? No. So we have some very, very rare stuff on here in terms of percentages. Yeah, so just some interesting things to consider. Well, that's all I have to share with you guys today. I want to practice a little bit more with you.